Getting lost in the unknown has always been one of humanity's greatest fears. That's why we made maps, to share the paths we've discovered. As programmers, we need maps too, or we risk wandering in circles.
Welcome to the journey. I'm Coda, and this path leads to mastering Android. But no one climbs these mountains alone.
Hello, you can call me No Name, your instructor. I'll be walking you through the technical concepts and making sure nothing stays confusing.
The first field we're diving into isn't how to write code in Java or Kotlin, but something else entirely. Our journey starts from zero, and we'll go step by step.
The very first thing you need to do is visit the official Android Studio website and download the latest version. That's the tool we'll use to build our Android apps.
Sure, using the latest version is ideal. But right now, I'm using the Dolphin version, because the newest one needs a powerful computer to run smoothly. Either way, we've officially begun.
Android development doesn't start with writing code. First, you need to configure some important things inside Android Studio.
I know, it can feel a bit frustrating at the beginning. But trust me, understanding this setup now will save you tons of time later.
Now let me introduce you to something called Gradle.
This thing is probably the #1 reason for errors in Android development.
Gradle is the build system used by Android Studio. Think of it like a factory. It takes your code, images, layouts, and turns them into a complete Android app you can install. It doesn't just compile your code. It also manages libraries, handles resources, runs tests, signs your app, and prepares it for release.
Every time you click Build or Run, Gradle starts working. It follows build scripts, step-by-step instructions on what to do.
But Gradle on its own doesn't understand Android. It's just a general build system. To handle Android tasks, like compiling XML or generating APKs, we use the Android Gradle plugin, or AGP.
Wait, so Gradle and AGP are separate?
Exactly. AGP is the plugin, made by Google, that teaches Gradle how to build Android apps. AGP adds Android-specific steps. Without it, Gradle wouldn't know what to do with files like Android Manifest, XML or Kotlin code.
Think of it this way. Gradle is the builder, AGP is the Android blueprint, and your code is the material. And learning this now helps you know where to look when errors pop up, because they will. Before we open any files, let me show you the structure of a typical Android project and explain what each Gradle-related file does. Did say it like hiccup?
Not bad. But not close.
Alright, champ. Time to get our hands dirty. First, open Android Studio. If it's your first time, it might take a minute to set up. Now click on New Project. Choose Empty Activity. We don't want anything fancy just yet. Set the language to Kotlin. That's what we'll be using in this series. Give your project a name, like My First App, and hit Finish. Okay, Android Studio will take a moment to build everything. And boom, this is your project. Now here's the cool part. See this folder called Gradle Scripts on the left? That's Gradle files.
This is Gradle file map you need in an Android project. Let me walk you through each of these files and show how they work inside our Gradle factory. Build.gradle, project level. This is the central control panel for your entire project. It defines shared plugins, dependencies, and repositories that every module can use. Think of it like the main control room of a factory. Settings.gradle. This file tells Gradle which modules or subprojects exist. It's like a factory map showing how many production lines you have. Gradle.properties. A place to define general configuration settings or global variables. You can use it to optimize performance or tweak build behavior. In our factory analogy, it's like the environment settings, temperature, speed, or build.gradle, module level. You may have noticed, there are two files named build.gradle. The first one, we already talked about it. It's like the control room for entire factory. But this like the instructions given to a single production line. Yes, a project can have more than one build path or unit. In Android Studio, we call each of these a module. A module is a self-contained unit of code, like your app, a library, or even a test suite. Each module has its own build file. It controls the specific settings, plugins, and dependencies for that module. Gradle wrapper.properties. This file locks your project to a specific version of Gradle. That way, anyone working on the project uses the same version. It's like making sure every factory uses the same version of the machine. Understanding these files is the first step to mastering Gradle. Don't worry, we'll go through them one by one and actually work with them as we build our app.
Let's look at this block of code from the project-level build.gradle file.
What language is this? It doesn't look like Java or Kotlin.
Good catch. That's Groovy, a scripting language that Gradle uses to define build scripts. Think of it like a flexible way to tell Gradle what to do. It's simpler and more concise than Java, and perfect for writing instructions like add this library or set this SDK version.
So, do I need to learn Groovy to build Android apps?
Not really. You just need to understand the structure of the build.gradle file. Most of the time, you'll be copy-pasting and tweaking a few lines, like adding dependencies or setting your app version.
Alright, so here's what each part does inside the project-level build.gradle file. Think of this file like the factory setup guide. You're not building your app yet, you're just telling Gradle what tools it needs to even start building.
First, there's the build script block. Think of this as the supply line for the factory. It tells Gradle what it needs before it can even start building your app.
Supply line? Like, tools and materials?
Exactly. One part of that is called repositories. It tells Gradle where to go shopping for its tools, like plugins and libraries. Imagine the factory needs a special screwdriver. Where should it buy it from? Repositories answers that, go check Google's repository or Maven Central.
And this is super important when using open source tools in your app. Before you add a library to your dependencies, you must be sure Gradle knows where to find it. If you forget to include the right repository, Gradle will say, sorry, I don't know where to get this.
The dependencies block inside build script is where you list the tools and helpers Gradle itself needs to start the build process. Think of it like a factory bringing in specialized machines before production starts. One machine to build Android apps, another to understand Kotlin code. This list ensures Gradle can function properly during the setup phase. And I say this file because there's another dependencies block somewhere else, and it serves a completely different purpose. Now, let's look at the other file that also contains a dependencies block.
This build.gradle module file looks like it's casting spells to be incomprehensible.
I have an anti-spell. Okay, let's talk about the plugins block. It might look simple, but it's super important.
You know how in a factory, you can't start building something unless you know what you're building? Are you building a car? A toy? A chair? Each one needs a different set of tools and rules.
Annotada. That's exactly what the plugins block does. Now let's explain it clearly. id com.android.application. This tells Gradle, we're building an Android application, a full app that you can install on phones. id org.jetbrains.kotlin.android. This means, we're going to write this app using the Kotlin language. So now Gradle knows it needs to support Kotlin in the build process.
Alright. Now we've reached this magical part of the file, the Android block. This is where we tell Gradle some really important information about how to build our app, like which tools to use, which Android version it supports, and how to identify the app.
Let's break it down. Compile SDK 31. This tells Gradle, use API level 31, which matches Android 12 when compiling the app. It doesn't mean your app will only run on Android 12, it just means the factory is using those tools during the build. Each Android version has an API level, think of it like a technical ID. For example, Android 10 has API level 29. Android 11 has API level 30. Android 12 has API level 31. Android 13 uses API level 33. Android 14 is API level 34.
Yeah, and don't forget, if you haven't installed SDK 31 in Android Studio, you'll get a big red error like. Believe me, I've been there more times than I can count. To fix it, here's exactly what you need to do to download SDK 31 in Android Studio. Open Android Studio. Click on the top menu, Tools SDK Manager. A new window will open. Make sure you're on the SDK Platforms tab. From the list, look for Android 12.0, API level 31. Check the box next to it. Then click Apply, and then OK. Android Studio will start downloading the SDK for you. It might take a few minutes depending on your connection. Once it finishes, you can rebuild your project, and voila, the error is gone.
Going back. Application ID com.example.myapp. This is the unique ID for your app. Think of it like your app's passport number. It must be unique, it's how Android and Google Play know this app from any other. MinSDK 21. This is the minimum Android version your app can run on. API 21 equals Android 5.0, Lollipop. So you're saying, our app can't work on anything lower than Android 5.0. Target SDK 31. This also doesn't mean the app is only for Android 12. It means, best match of Android versions. Usually, your target SDK is the same as your compile SDK. Why? Because you're building the app with the latest tools, and you're saying, I know how Android 12 behaves, if there are new restrictions or permissions my app is ready for that. Now let's look at build types section. This section is like saying, hey Gradle, here's how I want you to build the release version of my app, the version I'll put on the Play Store. Let's break it down. Release block. This is the part that defines how your app behaves when you're preparing it for publishing. Minify enabled false. Normally, when you're releasing your app, you'd want Gradle to minify your code. That means removing unused code, shortening variable names, and making it harder to reverse engineer. But here, it's set to false. It's like saying, I'm not ready to pack everything tightly, just give me a readable version of the release. But in a real app, especially in large apps, you should enable this to reduce app size and protect your code. ProGuard files line. This line says, if I ever enable minification, use these ProGuard configuration files to control what gets removed, what stays, and how to obfuscate the code. Think of it like a packing instruction sheet. Keep these items, rename those, and don't throw that one away. Get default ProGuard file, ProGuard Android optimize.txt, is the basic recommended setup from Android. ProGuard-rules.pro is a file you can edit to write your own rules.
Alright, remember when we said there was another file also has dependencies? Here we are.
But here it has other job, here where you tell Gradle what external features your app needs, like tools for networking, user interface components, databases, and more. Now here's something very important. Remember, the build script.dependencies are for Gradle itself, helping it build the project. But the dependencies here are for your app, the features and libraries it will use while running. And whenever you add a library here, you're basically telling Gradle, go online, download this specific library version, and make it part of my app.
That's why the version number has to be correct. If it doesn't exist or is misspelled, Gradle will give you an error. Alright, that's enough brain fuel for today.
You survived Gradle. Not bad for day one.
Yeah. One small build file for code. One giant leap for me. If today's episode helped you even a little,
then hit like. Leave a comment. Let us know you're learning. Next time, we will level up.